एवरीवन, वेलकम बैक टू माय चैनल। वेलकम टू स्टडीज विद जॉय। आपका स्वागत है हमारे चैनल पे। एंड आवर टुडेस टॉपिक इज साइंस पार्ट 2, चैप्टर नंबर 18, ऑब्जर्विंग स्पेस टेलीस्कोप्स. This video is the part 2 of this chapter. If you have not watched the part 1, you must watch it because it's very important. And also that video contains the basic part of this chapter, which is very necessary to understand the today's part. Now let's start with our today's topic. We have done many topics in the part 1, and I have given also the description in the description the link of the part 1 video. You must watch it. Now let's start with our today's topic. If you're new on my channel, then please subscribe my channel and also press the bell icon button so that you get the first notification when we upload a video. Now let's start. So in the first part of this video, we have learned about optical telescopes, which is a type of telescopes, and we have learned about the types of optical telescopes. Like there are two types: refracting telescopes and reflecting telescopes. And reflecting telescopes were of two types. First was Newtonian telescope and second was Cassegrain telescope. Now in the ending part of the first part of this chapter, I told you that there are much more telescopes like radio telescopes, X-ray telescopes, and we are going to learn about those only in this video. So first let's see what is a radio telescope. अब रेडियो टेलीस्कोप आपने सुना होगा नाम, तो आपको लगता होगा कि रेडियो और उसके ऊपर टेलीस्कोप और उसको ऐसे भेज दे. It's not like that. Its name is radio telescope because it collects the radio waves coming from the heavenly objects. Now let's learn about it. Many heavenly objects emit radio waves in addition to visible radiation. So only not the visible rays, but also the many heavenly objects emit the radio waves. But what happens is radio waves are not of the wavelength 400 nanometer to 800 nanometer, which is needed for our naked eyes to see it. So we cannot see this radiation with our eyes. Hence a special type of telescope is used to receive these rays. It is called a radio telescope. So this is the what is the answer to what is a radio telescope. It is made from one or more dishes of a particular parabolic shape. So how it is made? It is made from one or more dishes. I will show you the diagram, and it is made of some particular parabolic shape. Okay. And as in optical telescope, the incident radio waves are reflected by these dishes and converged at the focus. A radio receiver is placed at the focal point. The information gathered by this receiver is passed on to computer, which analyzes it and constructs an image of the source. So this is the whole working of radio telescope, which I will explain with a diagram. So here the first diagram is of a radio telescope. Okay, so this radio telescope, you can see here. So here what is happening, you can see that the source radio waves are coming. They're getting reflected from this and going here, collected at this point, and it is collecting it and sending to the amplifier, and it is analyzing and it's sending to computer, which analyzes it and gives us a magnified image of the source from which the radio waves are coming. So this way a radio telescope works. I hope that you understood what I am telling you. Okay, now let's learn about one of the most important radio telescope, which is Giant Meter Wave Radio Telescope, GMRT. We shortly say it as GMRT. A large radio telescope called the Giant Meter Wave Radio Telescope, GMRT, has been erected at Narayangaon near Pune. So as the name of it has giant, so it is the very big, large radio telescope. It uses radio waves having wavelength of about a meter coming from planets and stars to study those heavenly bodies. This telescope is actually a collection of 30 dishes each having a diameter of 45 meters. So this telescope is collection of 30 dishes. Normally a radio telescope is collection of 3 or 2 dishes, but it is such a huge that it needs 30 dishes of diameter 45 meters. So it is the structure of it which can be asked you as a question. So remember this point. It is called a giant telescope as the arrangement of the 30 dishes over an area which measures up to 25 km across is made in such a way that it works as a single dish having a diameter of 25 km. So the arrangement of these 30 dishes, which totally form a diameter of 25 km, are like that it looks like only one dish which is of diameter 25 km, and it is such a huge, that's why it is called as giant telescope also. This means that the GMRT gives the same data that we would have got from a telescope having a single dish of 25 km diameter. So this means this will also give the same data that we can get from a small radio telescope. GMRT has been made by Indian scientists and engineers at minimum cost, at a very less cost, which should be from expectations. The GMRT has been made by Indian scientists and engineers. It is a world standard research facility because it creates a very magnified image, and it is very clear due to its lot of combination in it. Scientists study the solar system, solar winds, pulsars, supernova, interstellar hydrogen clouds, etc. with the help of GMRT. So these many things are just studied by this GMRT. Scientists from all over the world come to India to make use of this facility. So from all other countries also scientists come to India for using this facility of GMRT because it's so huge, so it can collect so much, a large amount of radio waves, and it will create also a good or clear or bright image. Okay, so it's a very proud moment for Indians, because for this the scientists all over the country come here to use this facility. So this second image I have shown here is of GMRT. You can see so huge they are. Now let's learn something or some telescopes in space. So actually these all telescopes that we learned were only on Earth. Optical telescopes, Newtonian telescopes, Cassegrain telescopes that we learned about using them as on Earth to see the heavenly bodies from Earth or collect the light. But there are some telescopes which have been sent to the space. Okay, so we are not having it here. They have been sent to the space by the scientists, and they get a more bright image and more perfect image. Okay, now let's see and learn about them. Visible light and the radio waves emitted by heavenly bodies in space can pass through the Earth's atmosphere and reach the Earth's surface. So the visible light and radio waves emitted by heavenly bodies that we learned till now can pass through the Earth's atmosphere and reach the Earth's surface. Okay, so optical and radio telescopes can be erected on the surface of the Earth, and we can get an image. However, these Earth-based telescopes present some problems in making good quality observations. But these Earth telescopes that are optical telescopes and radio telescopes present some problems, even because they are on Earth and they are collecting the waves. We can collect because they are coming, visible light and radio waves, and we are able to collect also. But there are some problems due to which we do not get a clear image. Let's see some problems. The visible light coming from a heavenly body has to pass through the Earth's atmosphere to reach the Earth's surface. Okay, during this journey, some of the light is absorbed by the atmosphere and intensity of the light reaching the Earth's surface decreases. So let's see the difficulties of visible light first. So visible light has to pass through the Earth's atmosphere to come to the to reach the Earth's surface. Now during this journey, some of the light due to the Earth's atmosphere, it is absorbed by the Earth's atmosphere, and the intensity of the light reaching the Earth's surface decreases. A second problem is caused by the changes in atmosphere pressure and temperature. So the changes in the atmosphere pressure और जो मौसम बदलना, ये सब की वजह से and temperature also, these all affect these lights and their direction. These changes cause turbulence in the atmosphere, which in turn cause of the light rays to change their path slightly and thereby shake telescopes during the day. Okay, thereby shake the position of the image. So image की जो position है वो भी shake हो जाती है क्योंकि उनकी direction बदल जाती है. Also, because of sunlight, we cannot use optical telescopes during the day. So, due to the sunlight being there, we cannot use optical telescopes during the day. Okay. During the night, too, city lights and cloud weather can cause difficulties in observing the heavenly bodies. At the night, also the city lights can also causes problems, and also the cloudy weather also causes problems in observing the heavenly bodies, because there are so many clouds in the night now. To reduce these problems, optical telescopes are situated on top of mountains, that I told you first only in the first part. At in uninhabited places, means the place where nobody lives, there are the optical telescopes situated, because there are no satellites, city lights in the night there, and daylight then also we cannot see, but in the night there will be no city lights or ट्यूब लाइट की रोशनी, वो सब नहीं होगा क्योंकि वहाँ पर कोई रहता नहीं. And we can and it will be at a higher place also, so that we can see it more clearly. But this doesn't clear all the difficulties. There are some difficulties still, but this just reduces these difficulties. However, if we want to get rid of all the above problems completely, we should place the telescope above the Earth's atmosphere in space itself. So to get rid of all these difficulties, we should have launched the telescope above the Earth only, which will be more better, because then it does then the radiations should not don't want the radiations are not necessary to pass through the Earth's atmosphere. Okay, are you understanding what I am saying? These problems do not exist in the space, and thus the image obtained by space telescopes would be bright and very clear and will remain at one place. So the images obtained by the telescopes in the space are very much bright and very clear, and they are at their position is not changed. Scientists have turned this idea into reality. Scientists have made this idea into reality also by launching the telescopes with satellites. Now let's learn about some telescopes, that Indian telescopes which have been launched to the space by India. Indian telescopes in space. In 1990, the National Aeronautics and Space Administration launched into space in an optical telescope called the Hubble Telescope. It has a mirror of diameter 94 inches and is orbiting the Earth at a height of 589 km from it. This telescope is still working and has helped to make important discoveries. So, in 1990, the National Aeronautics and Space Administration of India had launched an optical telescope which is named as the Hubble Telescope in the space, and it has a diameter of 94 inches, and it is above 589 kilometer the Earth. And this telescope is still working, and it has helped to get very important discoveries. So this is the Hubble Telescope. Can you see? Okay, so in this image it doesn't look that it's so above the Earth, but actually it is so at a very big height than the Earth's atmosphere. Second one, the Indian telescope which has been launched into the space in 1999. In 1999, the National Aeronautics and Space Administration launched an X-ray telescope named Chandra in space to study X-rays coming from heavenly objects. So the heavenly objects also emit X-rays. So these X-rays are studied by X-ray telescopes. And in 1999, the National Aeronautics and Space Administration launched an X-ray telescope named Chandra. Special mirrors which can reflect X-rays were used in this telescope. So the very special mirrors were used in this telescope which can reflect the X-rays. Chandra has given us very useful information about stars and galaxies. The telescope is named after the famous Indian scientist Subramaniam Chandrasekhar. So it is the telescope named after the famous Indian scientist Subramaniam Chandrasekhar. So this is the Chandra Telescope. Can you see? It's very huge, and it has helped to discover many facts about stars and galaxies. Now let's learn about the organization ISRO in India, the Indian Space Research Organization. It is situated in Bengaluru. This institute was established in 1969 with the aim of developing technology of making and launching of artificial satellites. So of developing the technology and artificial satellites launching is the aim of this institute. Till date, ISRO has successfully launched a large number of satellites. Till now, ISRO has launched so many satellites into the space. Even the story of um, um, the story that ISRO had launched a satellite the to the to the planet Mars. Yes, it was in the first try. It has reached Mars, and it was very proud moment for India to do it in the first try only. So this is a fact and very important thing that you must know about our country. Okay, ISRO's program is foremost among the successful programs undertaken by independent India. India's progress in space science has played a big role in national and social development. So India's progress in the science has made a very big role in national and social development of our country. The INSAT and GSAT series of satellites support a telecommunication network, television broadcasting and meteorological services. So very important fact this is which you would be not knowing. हमारे घर में सबके घर में टीवी तो होता ही होगा. टीवी पे जो ये आता है सीरियल्स, कार्टून्स एंड एवरीथिंग विच इज टेलीकास्टेड ऑन द टीवी is telecasted with the help of these two satellites. They are INSAT and GSAT. These are a series of satellites for telecommunication, that is television. Okay, so this is the satellite from which the news channels and these serials, everything is telecasted all over the country. It is because of them that telephone, television and internet services are available everywhere in the country, and they also help in these telephone calls. So these only the satellites because of which you can call your friend, call your mom, dad, everything you can do. The EduSat satellite in this series is used exclusively for education. So EduSat satellite is used for education. This is a special satellite. It is used for education in our country. In TVs, you would have seen education programs 24 hours are going on. The IRS satellite series is used for the monitoring and management of natural resources as well as disaster management. So the IRS satellite is used for managing disasters. Means with the help of this satellite, we can find it out. So, somewhere some problems are going on, so tsunami can come, so they can give a alert. Okay, and that comes in meteorological department, and also management of natural resources. Okay, so these all are done by IRS satellite with the help of it. Now let's learn about the recently launched satellite by ISRO, AstroSAT. In 2015, Indian Space Research Organization (ISRO) launched an artificial satellite called AstroSAT in space. This satellite has ultraviolet and X-ray telescopes and detectors. So, AstroSAT is an artificial satellite, okay, which has X-ray telescopes and detectors, and also ultraviolet telescopes. It has. Most of the bands used in this satellite are made in India. It is a unique system having different kinds of telescopes on a single satellite. So it is a very unique system because a satellite has so many different kinds of telescopes, and Indian scientists are studying various aspects of the universe till now using the data obtained with these telescopes. Okay, so this is not a telescope launched into the space. It is a satellite launched with a different kind of telescope in it. Okay, I can show you the picture. This is the picture. You can see in the picture so many telescopes you can be seeing. So this is the AstroSAT satellite. With this we complete this chapter number 18, observing space telescopes, and now let's look forward towards the notes of this chapter. Question number 1 is fill in the blanks with the proper words. The answers I will tell you orally only. They are very simple answers. Okay, so you can write it down. First one is the wavelength of visible light is between dash and dash. Correct answer is 400 nm and 800 nm. Nm is nanometer. Next question is GMRT is used for dash waves. Answer is radio waves. Okay. Next question is a certain X-ray telescope is named after scientist dash. Answer is Chandra Subramaniam. The answer is Subramaniam Chandrasekhar. Next question is the first scientist to use a telescope for space observation. Dash. The correct answer for this question is the answer will be Galileo. Next question is the biggest optical telescope in India is situated at Dash. Correct answer is Nainital. We have learned in the first part. Okay. Now let's do the question number 2. That is compass. The correct answer for X-rays. X-ray is used in which telescope? Chandra Telescope. अभी हमने पढ़ा. I hope that you remember it. Okay. So I will give you the answers. Okay, I will provide you the answers. X-rays is Chandra Telescope. Optical telescope is Hubble because it was an optical telescope. An Indian radio telescope is GMRT, the biggest. And launching artificial satellites is the function of or aim of ISRO, that is ISRO. Okay, so this was the answer. Okay, now let's do the question number 3. That is, what are the difficulties in using ground-based optical telescopes? How are they overcome? The whole answer is in front of you. I have explained you all these difficulties, that the sun rays are there, and also at night city lights are there, and cloudy weather is there, and also the intensity decreases because of the Earth's atmosphere, because it absorbs the light rays. So these all are the difficulties, and if you want the answer you can note it down or take a screenshot. Next question, question number 4, very important. Which type of telescopes can be made using a concave mirror, convex mirror, plane mirror and a lens? This we are learned in part 1, that optical telescopes and telescope made with lens, that is reflecting telescopes, then reflecting telescopes like Newtonian and we can say that Cassegrain. So we have to draw the diagrams also. Diagrams can be asked in your question exams. So this is the first one, refracting telescopes. First you will mention that optical telescopes are made using a concave mirror, convex mirror, plane mirror and a lens. Then you will start that these are of following types. You will first write refracting telescopes. It uses a lens for objective and eyepiece. You will draw this diagram. Then you will write reflecting telescopes. You will write A and B as two types of reflecting telescopes. That is, A is Newtonian telescope. It uses a concave mirror, a plane mirror and lens. Draw a diagram. Then write Cassegrain telescope. It uses a convex mirror, a concave mirror and a lens. Draw the diagram. Now let's do the question number 5. Study the figure and answer the following questions. The figure is not visible too much, but you can see in your textbook and answer or note down the answers. First question is, what type of telescope is shown in the figure? The above figure shows Newtonian telescope, which is a type of reflecting telescope. Next question is, label main parts of telescopes. You can also do this from your textbook only, it is mentioned. Next question, third, which type of mirror does the telescope use? Answer is, Newtonian telescope uses concave mirror and plane mirror. We have learned about how the working is in the part 1. Fourth one is, what other type of telescope uses a curved mirror? We knew that Cassegrain telescope also used a convex and concave mirror, which are curved mirrors. So Cassegrain telescope uses curved mirrors. Next, fifth one is very important question. This can come in your exams also. Explain the working of the Newtonian telescope. So I hope that you have understood. I have shown you with the diagram also in the first part, and you can note this answer or take a screenshot. Next question is question number 6, final question. Answer the following questions. First one is, explain the construction of Galileo's telescopes. So here it's a small answer, you can note it down. Next question, explain the construction of a radio telescope. So I hope you know this. I now only we explained you how a radio telescope works, how it's a parabolic shape. You can note this answer, and you if you draw this diagram, it's much more easy, okay, to make you understand, or for it will look good better. Why are optical telescopes located in uninhabited places on mountains? This is the third one, C. The answer is in front of you. The same mention you will do, that visible light coming from the heavenly body has to pass to the Earth's atmosphere. During this journey, some of the light gets absorbed, and these solve problems that they face. Last question, fourth one. Why can an X-ray telescope not be based on the Earth? X-ray, this is very important and this can come in your objectives also. X-ray telescope is a telescope that is designed to observe remote X-ray emitting objects in space. Earth's atmosphere blocks almost all the X-rays coming from space. Okay, this is very important. Like name the following, it can come that which type of telescope are not based on the Earth. Okay, hence X-ray telescope should be placed above the Earth's atmosphere and cannot be based on the Earth. Now we finished with this chapter, and we also finished with all the chapters of Science 1 and Science 2. Thanks for watching. We have completed the portion. Now let's thanks for watching. If you like my video, then please subscribe my channel.